Honors Geometry Note Section 12.1, Circle Transformations. Fact, all circles are similar. They all have the same shape, they could be different sizes. Let me try to illustrate this. First of all, if I take this little circle, and I want to show that it's similar to the big circle, I could first line up the centers using a translation, I should say. This one looks like it's going to go to the right a bunch and then down a little. Once I get here, I can take the circle, and if I dilate it by the correct number, I can make this the exact same as the other triangle, which is what similarity means. Similarity means same shape, they're both circles, and you can multiply one by a scale factor and it becomes the other. So I could make this any size that I wanted. This is just trying to illustrate that all circles are similar. Same shape, could be different sizes. Show how circle A and B are similar using similarity transformations. Well, we are first going to translate, we're just going to do formally what we just discussed in the previous one. Circle A by vector AB. Here's vector AB. That just moves A right on top of B. Then we're going to dilate by something. We're going to dilate by the scale factor. And if you recall, what we did in the past was scale factor. We took the pre-image times k, where k is the scale factor, and that equals the image. To get k by itself, that's going to be the image over the pre-image. Now, when I write pre-image and image, I'm talking about the size of something. Could be the length of a side, could be the perimeter, could be lots of things. We're going to be talking about radius in this regard. Pre-image is old, image is the new. So one way to look at this is the scale factor is always going to be multiplying by the new and dividing by the old. You multiply by the new and you divide by the old. So in this case, the new radius is R and the old radius also R. The new one's capital R and the old one's lowercase r. This fits with what we used to do, what we were doing before. We can do it the old way as well. The pre-image, little r, times the scale factor equals the image, big R. So k is big R over little r. Scale factor is the new over the old. Image over pre-image. So this is saying exactly what we just wrote up here. Just saying it for you. Let's put this into practice and see if we know what the heck we're talking about. Determine the translation vector and scale factor of the dilation for the following similarity transformations. So it says which direction to go, A to B. That means this is the pre-image and this is the image. So to go from A to B, we're going to have to go to the right, 1, 2, 3, 4. So that's vector notation, right 4. We're going to have to go down 1, 2, 3, 4, 5, 6, 7, 8. Down is negative, up is positive. Left is negative, right is positive. So to get from A to B, we have to use the vector 4, negative 8. Then, remember this notation, dilate about point B. What are we dilating? We're dilating circle A, and that's going to give us circle B. I don't know how this got cut off. This is supposed to be up here. This is the scale factor. That's what we're missing. So what is the scale factor? If we think of scale factor as new over old, the new radius is 1, 2, 3, 4. The old radius is 1, 2, 3. We're going to dilate it by a scale factor of 4/3. Once again, this fits in with how we used to say it and how we used to say it's fine, which is preimage times k equals the image. The preimage's radius is 3. The image radius is 4, so k is going to be 4/3. It's a lot of turds. Here we're supposed to go circle B to A. So we got to translate this fella to the right one. That's plus 1. And down 1, 2, 3, 4. Down's negative. So that's a vector 1, 4. 1, negative 4, I should say. And then we have to dilate about point A, the new radius, 1, 2, 3, 4, 5, 6, 7, over the old radius, 1, 2, 3. Dilate by 7/3. Cool? Cool. That concludes the notes for section 12.1.